Hey guys, welcome back to my YouTube channel. So in this lecture, we are going to start an Hall effect. So which is one of the very important effect that we use to classify the semiconductor devices. So if you guys go through this, the exact definition that I wrote, I'm sure that you guys won't understand anything. So let me first explain the concept and then let's get into the picture. So let's take a 3D structure here. So I will draw with an example also. Okay. So this is x direction, x-axis, and this is y-axis, and there is an z-axis. So we have to keep a semiconductor where current is flowing. So we have to keep one semiconductor where some current is flowing. So this is the semiconductor. It will be good if we have 3D structure. So I'm not expanding it into 3D. Okay. For now, let's consider this. So we are considering the condition that the current is already flowing, the Ix, which is the current that is flowing. So there will be the distance d, that is the height of the semiconductor, or anything we can click it, and magnetic field is in z direction. So this is two things that you have to find. The specimen, the semiconductor physics, where the specimen is placed in the magnetic field where the current and magnetic field is 90°. Then what will happen? The force will make the charge carrier to move. So this is similar to Fleming's left hand rule. So you guys can also try it. So Fleming's left hand rule. So the forefinger will point to magnetic field. So adjust your fingers based upon those. Middle finger it will be directing to current, and then thumb it will point the direction where there is force. Force means movement of a charge carrier here. So middle finger is pointing to the magnetic field and forefinger is pointing to the magnetic field. Then you align the direction. The forefinger will point to your side. Okay, take your left hand and point the forefinger to your side. Invert it. Then you will see the thumb is pointing to downwards. So it will show that if we consider this as an n-type, so this is an n-type, then the charge carriers will move from top to down. All the electrons will move from top to down. Means it will form a negative potential down and positive potential upward. Means the electric field will be pointing from top to bottom. Right? You guys able to understand? So again I am letting know. Please point your left, take your left hand and make the middle finger to current and forefinger to magnetic direction. If you make that one, then thumb will pointing to downwards to ground and forefinger will point to yours. Take your left hand and right. It will show the thumb the direction where the force will act, means the charge carrier will move to down direction. We know that the charge carrier is moving there, then the top will be occupied by holes or some kind of reverse potential. So below is negative and top is positive. So the electric field EH will be developed here. Okay. So then there is a width. So this is the width of the semiconductor and this is the distance, height or distance of the semiconductor. So I hope it's understood for you guys, right? So this is the thing. So now how we can classify semiconductor from this one? So let's take, this is the phase 1 upper phase and downside is the phase 2, as it is a cube, right? So let's take a diagram for our understanding. So let's take two things. Okay. So here you see the top one is phase 1, below is phase 2. So if you see the top is positive, positive, positive and lower is negative. As you see, electrons are moved to downwards. So this is n-type. because the electric field is pointing to downside. If it is in p type, what will be the potential or the voltage, sorry, electric field that will obtain is the in the phase 1 where will be negative and phase 2 will be positive, because all the holes present here, right? So that will be moved to down direction. So we can clearly see the electric field will point from this to this direction. Here the electric field is from this to this direction. So based upon this electric field created, we can able to classify that is n type or p type. So that is why the importance of Hall effect. So if there is equal holes and electrons are equal, that is an intrinsic semiconductor, then there will be no voltage will be produced. For electric field, there will be corresponding voltage production, right? If the voltage is positive or negative, based upon this conversion, we can able to find out that is n type or p type. So if VH is 0, then we can say that is an intrinsic semiconductor. Okay. So how we can find out the VH? So VH is the voltage that is developed in Hall effect, that will be based upon electric field, current, and dou W. W is the width and dou is some kind of constant, that is charge density. Dou is charge density. Okay. This is how we can use the Hall effect to classify the semiconductor. So we have also another one constant, that is Hall's coefficient. Hall's coefficient, that is RH. So RH, which will be basically depends on electrical field J, the charge density, to that of magnetic field. So E can be written as V divided by distance, right? VH divided by distance. So JB. So it will be equal to VH divided by JB into D. So if we substitute the coefficient value, that is the value from the previous equation, then we will be getting VH, that will be equal to BI divided by JW rho into B and D. So the B can be cancelled here. So if we cancel the B, then RH, which will be equal to I divided by rho J A, because the charge carry concentration, like the rho and D, sorry, not rho, W and D can be written as A. So area which can be written as W and D. Okay. So this value will be cancelled. Okay. So we will be getting this. So if we I divided by A is J. So J divided by rho by J. So these J can be cancelled. So 1 divided by rho. So the Hall's coefficient will be directly equal to 1 by rho, that is charge density. Okay. So I hope you guys can came to know that how Hall effect is used to find out the thing. So one of the major application of the Hall effect is that it is used to classify the, used to identify type of semiconductor. First thing is that identifies type of semiconductor. Identify type of semiconductor. Identify the type of semiconductor. And then used to identify the majority charge carrier concentration. Also to find majority and minority charge carrier concentration. That thing also can be found out with this majority and minority charge carrier concentration. Based upon the potential that will be built, right? So majority, not minority, we can calculate only majority only, because minority will not be taken into consideration as it is behave with the majority charge carrier concentration. So majority carrier concentration as well as mobility concentration and mobility, based upon the movement of charge carriers and mobility. Okay. And then also we can measure magnetic field strength. Okay, so these are the three important application. Please remember these things, so we can even expect a direct question from this one. Okay, so I hope we have covered pretty much everything. So from next lecture, we can have one problem discussion, like from the Fermi distribution level. I will be giving one problem session tomorrow. After that, we can directly kickstart into PN junction diode. I hope you guys understood all the semiconductor device concept as well as continuity equation and Hall effect. So this will be very good. Now we can go to this definition. So when a current carrying specimen is placed in magnetic field, where magnetic field and current is perpendicular to each other. Here you can see current carrying specimen is placed where current is in x direction and magnetic field is in z direction. So both are perpendicular. So then an electric field will get developed in the direction perpendicular to both. So you see, because of the charge movement, the electric field and the potential will be developed there. So that is perpendicular to both direction, that is in y direction. So that is what the statement that they are given in the Hall effect. So I hope it is understood for you guys. So please like, share and subscribe the channel. Stay tuned for next lecture.